Hello, my name is Zachary Winger, and I decided to do my final project on creating a simple 3D scanning system. The goal of this project was to generate a 3D representation of a small space using the ultrasonic sensor included in the Arduino starter kit. I wanted to do the most interesting project I could think of, based only on what came in the kit. The system will gather the height and dimensions of an object in a small space by changing the position of the sensor and gathering distance data. The stepper motor will be used for vertical rotation, and the servo will be used for the horizontal rotation of the system. The system will move the ultrasonic sensor through a horizontal and vertical field of view at 20 different points around the perimeter. Because the position of the system relative to the bounds of the square are known, we are able to recreate a 3D representation of everything contained within the square in MATLAB. Here you can see the device in its entirety and the horrible mess of rubber bands that holds it all together. Here you can see video footage of the system functioning. As you can see, the system stops at set angles throughout the horizontal field of view. It then notches up to the next vertical angle and does the same thing again. The number of stop points and both fields of view can be set in the program. When a scan is complete, the system waits a bit for the user to move the system to the next scan location, then resets. For initial testing, it was determined that a large, simple object would be the best to show off the functionality of the system. For this run, data was taken at 20 points around the perimeter, measured and marked with a Sharpie. There were some difficulties with interference when doing the initial testing. Using a program I wrote in MATLAB, we are able to reconstruct the data in 3D space. This was done using the known location and direction of the sensor, combined with some polar to Cartesian conversion. Initially, the data was very cluttered and hard to read, as there likely are a number of inaccurate readings from the sensor. In order to combat this, a simple filtering system was implemented. For every point, the program will determine if there is another point within 5 centimeters of it. If a point in the proximity exists, both points are kept. Additionally, every point that was outside of the bounds of the square was rejected. This simple filtering method provided us with much clearer results. As can be seen from this top-down view, the program accurately determined the location of the space heater in the square. There are still a number of miscellaneous data points, but that is to be expected when working with simple sensors such as this. Here is an isometric view of the same plot. It's a little difficult to see, but the program was able to determine the top of the space heater, which is about 40 centimeters from the ground. Here I have circled the location of the heater to make it a little bit easier to see. In conclusion, I was overall impressed with the functionality of the system. However, it is by no means perfect. There are many things that can cause inaccuracies, such as unintended movement of the sensor due to the mounting equipment, and inexact initial calibration. It would also be useful to collect a lot more data points, as it may make the overall readings more accurate. I also ran into some motor power issues, as the servo sometimes struggled to move the weight of the ultrasonic sensor against the resistance of the wires. In the future, using more powerful motors would make my life a lot easier. Overall, I learned a lot about Arduino, MATLAB, and sensors while doing this project, and I am interested in continuing development of this device. Thank you so much for listening, and have a great rest of your day.